let's take a look at a situation where we're going to need the normal distribution. So the scores on a math exam are approximately normally distributed with a mean of 72. So that means our mu is 72. A standard deviation of 6. So sigma is 6. And we're interested in knowing what percent of scores are above 84. So what we're really asking is what's the probability of our variable x being a single score, or what's the probability that a single score is above, so greater than 84. And one way to think about this is for our normal curve, right, to kind of at least get a picture of this thing. So 72 is there, and then if we increase by our standard deviations of 6, so here's 78, and then here is 84. It just so happens to be 84 is the value we're interested in. Now, this won't always be exactly 1 or 2 or 3 standard deviations away, but in this case it is. So we're looking for the probability that we are greater than 84, so to the right of 84. There are a few different ways to figure out that value. One of them is to start by finding our z-score. So we can do x minus mu over sigma. So 84 is our score of interest, and mu and sigma we already listed. And sure enough, we would get 2 for our z-score. So we could use our z-table. We could also use the function in our calculators that's normal CDF. So we have a couple different options to go with this. Now we could use the raw data and still use normal CDF in the calculator. We can use the standardized data and use normal CDF, or we could use the standardized data and again use our z-table. We might get slightly different results depending on which one we use. Right, the table is always going to be a little bit of an approximation, but it should be pretty good. The value I got here was 0.02275, I believe. Let me double check. That's the one. Okay, so another way to say that is, right, this would be as a proportion. If we're thinking probabilities, we usually want to think in terms of percent. So another way to say that is 2.275%. All right.